In this video, we will compare two different models using regression. So for regression, there are few common regression metrics that include mean absolute error, that is MAE, mean squared error, that is MSE, and root mean squared error, that is RMSE, and R square score, that is coefficient of determination. So in this video, I would use RMSE for interpretability, same units as the target, and R square for the model fit. Now for the model building, we need to select input features. So we have four input features here: temperature, exhaust vacuum, ambient pressure, and relative humidity. And we have the final output. So the actual output is given as P, which is uh, which is the hourly power generation output. So if we wanted to try to predict the output using the given set of input features, that is these four set of features, we would want to perform multiple regression. So multiple regression is used when you have two or more productive variables. Um, you have two or more predictive variables and one outcome variable. So we have this one outcome variable and we have two more than three input variables. So we have now raw data. So these are the raw data, and we will split these raw data into uh, training data and test data. So 80% of these will be training data and 20% of these will be test data. We run the regression model across all the input features and look at the test result. So now, to enable regression or to enable data analysis in Microsoft uh, Excel, uh, we have to first enable data analysis here. So for doing so, we have to, I have already enabled it in my Excel sheet. So now going forward, so based on these predictive input value, we have to uh, we have to find the predictive output. So when I go to data analysis and here regression is selected, so I'll stay as is. So after I selected regression and I had given the input feature and output feature. So let's say here input y range and output input x range. So in input y range we have I have selected actual output, which is outcome, and in input x range I have selected the input features, which is predictive value. So and then since in the first row we have levels, so I have selected levels here as well, and for the confidence level I have selected 95%. Now for the output range where I have to put my output, so I have selected this uh, H6. Now after I selected OK, this output has come as a predictive output for this regression testing. If I go down, this is the regression statistics, which is having multiple R, uh, which is 0.96 something value, and this is R square, which is 0.92. And I have also adjusted R square, standard error, and observations. So there are total 9,568 observations. Now going down the result, in the ANOVA table, we have regression. So we have multiple values for it. That is DF, SS, MS, F, significance F. And we have regression, and regression is done for the four set of input values. And we have residual value as well. And total is 9567, which is total of these many observations are there. Now, again, going down to the output, we have intercept, we have coefficients, standard error, t stat, and p value. And in addition to this, we have also lower 95% and upper 95%, which we have set as a percentage. This is lower 95% and upper 95%. Now, coming down to residual output, these are the residual output for the all the observations which we have here. Now, how we calculate the residual outputs? So basically, we we take the predicted output, which is here, like for the first observation, which this is here 467 point something. So if we subtract this predicted output from the actual output, sorry, from actual output to the predicted output, we get the residual value of -9, -4 here. So this is how we get residuals for all the set of observations which we have here in the Excel sheet. Now, if we correlate the predicted output value and the actual output value, so we have to see the multiple R square here. So if we come here and we put a correlation between predicted output and the actual output, this gives a value of the same as which is here standing here in a multiple R. Now, if I square this input value, multiple R value, which is here J6, and then shift enter into 2, it comes the same value which is given here as a R square. It means that 92% of the total predicted value is the variance, is the coefficient. Now, similarly, if I go for the regression 2 model, here I have taken only 3 features. In regression 1, we have 4 set of features, predictive input. Here we have taken 3 set of predictive input, and we have 1 actual output. So, exhaust vacuum and ambient pressure and relative humidity. Here I will be taking temperature as a null, which is I will be making coefficient 0. And why I'm making coefficient 0 here is temperature is the only factor which is varying a lot. And there is a lot of variation in this temperature coefficient. So taking temperature coefficient as 0, I'm predicting the output value on these 3 set of features, which is exhaust vacuum, ambient pressure, and relative humidity. Now coming to the summary output. Similar way, the way we did for regression 1, we have put it here in the data analysis, regression, and as an input Y range, we have selected the set of output value, which is given as a P. And for the input X range, we have selected the 3 set of features, excluding temperature. Similarly, we have selected labels and confidence level, which is 95%, and the output range, as well as residuals. I'm not selecting anything else here. So putting that as a value, I'm receiving these regression statistics. Now, looking at the ANOVA table, we have regression as DF as 3, SS as 224, 0388, MS, F, and significance F. Residual value is 9564, and total value is 9567. So considering all, we have the total observations as 9568. We have multiple R value as 0.89. And if we square this as a multiple R, we get the R square value as a 0.80. We also have a standard error, coefficients, T stat, P value, and lower 95% and upper 95%. And then following that, we have residual output as well. And how we arrive to that residual output is we have subtracted this predicted output value from the actual output value, and we got the residuals value of -9, that is -9. And this is the way we find the value for all residuals value for all the observations, that is 9568. So this is how we compare multiple models in the regression testing, and we select the best model. Thanks.